Hey there. Today we are working on using function notation. So function notation is all similar with this linear equation stuff. We have y equals mx plus b. Remember, m is our slope, b is our y-intercept, and x and y are the points on that line, on that graph. Now, function notation uses f of x instead of y. So f of x equals mx plus b. So that's why I wrote f of x in quotations, because that's how you pronounce this. It's not f times x. Even though parentheses usually means multiplication, not for function notation. It's just a variable and it's talking about function f. It could be about function g. That would mean it's g of x. It could be of function m. That would mean m of x. So because this is about function f, which is usually the go-to, that's why it's f of x. Anyway, example 1. See how this is important and how you can relate this. You'll get a question like, what is f of x? When x equals -3 for this equation, f of x equals 3x minus 15. So what are we looking for? We're looking for f of x, and f of x is another way of saying y. So we're like looking for the value of y when x equals -3. All we got to do is plug in -3 for x. So we're looking for f of x. This is the equation. F of x equals 3x minus 15. We're plugging in -3 for x. Okay, so I'm finding f of -3, which is 3 times -3 is -9, minus 15 is -24, and that's my answer. So the value of f of x when x equals -3 is -24. Not bad, right? It's not 3f here, or I should have at least -3f. It's not that. That's that no symbol, because a lot of times I see this on this side. They put f of -3 correctly, but then they think, oh, this is multiplication. That's not multiplication. You're just saying that value of x is -3. All right. Let's get harder. It's still fine. All right. Example 2. For the function f of x equals 2x minus 10. Again, this could have been g of x. I just picked f again. Find the value of x so that f of x equals 6. So this is different. How is this different? What are we finding? What's our unknown? Your unknown, we're finding the value of x. So that's the one that stays as a variable, x. What do we know? We know f of x is 6. And what's another word for f of x? Y. So the whole left side of the equation is 6. So I have f of x equals 2x minus 10. I plug in 6 for f of x. Are you with me? Plug in 6 for f of x. And 2x minus 10 stays the same. I don't know x, it stays as a variable. And then look, I've got an equation. Solve it. One-step equation. 2 steps, but one variable equation. Add 10 to get rid of the -10. That means you have 16 equals 2x. Divide by 2. That is 16 divided by 2, and that's 8. So find the value of x. Did I do that? Yeah, x equals 8 when f of x equals 16. Not bad, right? So it's all about reading the vocabulary and making sure you follow the right steps. Always ask yourself, what am I finding? Finding x, that's my variable. Finding f of x, that's my variable. All right, last thing to do, fun fact, parent function. So there's a parent function for every type of function. What we're dealing with are lines, and those are linear functions. So for the parent function for linear functions, our equation is f of x equals y equals x. Same thing. So if I have a coordinate plane and I were to graph this, instead of y, I wrote f of x just so you understand it's still the same thing. They are equivalent. And x is x. So how would I graph y equals x or f of x equals x? So I got to think, what's my slope? What's my y-intercept? Nothing added on. So my y-intercept is 0. What's in front of the x? A 1. So I'm doing 1 over 1. So from 0, rise 1, run 1. Rise 1, run 1. And so you're literally cutting it right in half. So this equation, this graph, is the equation f of x equals x, y equals x. Now this is the example using this information, the fun fact that we just learned. Graph the function g of x g of x equals x minus 3 compared to the parent function. So let's first graph it. Remember this is like y equals, and I use g of x just to show you that it doesn't matter. It's just then g of x for our y. Anyway, so what's my y-intercept? It's -3. Where's that on my axis or my g of x axis? That's right there. Then I'm using my slope. What's my slope? Well, it's the one in front of the x. That's a 1, which is 1 over 1. So rise 1, run 1. Again, rise 1, run 1, rise 1, run 1. You can do it till your whole coordinate plane is covered and then go the other way. Down 1, left 1, down 1, left 1. Good. Draw your line. Now we need to compare it to this line. Well, it's a little bit difficult to do without graphing it, so I'm just going to quickly graph this. What's my y-intercept? For the parent function is 0. What's my slope? 1 over 1. So it's going straight through like so. Draw your line. So now let's compare these. Graphed it, compare it, compare it. What are they? The lines are parallel. Which means same slope, which you could also say they're both 1. And what's different? Their y-intercepts are different. One is 0, one's -3. So it's kind of like it shifted down. So if I were to start at the blue and move to the green, how did I move? I shift down how many? 3. From there, down 3. Cool. That's the end of this lesson. Yay.